Okay, we start with merge sort, and you need to watch the video. Let's go.
Example. Merge sort is usually done recursively.
Yep, check.
When you think of merge sort, as with other recursive algorithms, I want you to think of divide and conquer. We're going to break our problem into smaller problems in order to solve it. Let's get started. We have the following array and we want it sorted. We're going to continuously split the array in half, our divide step, until we are left with the individual items. Watch and see.
Watch. Split again.
Our array is now broken down into individual items. One note before we start sorting. When you implement this in code, these steps will be done in a different order because of recursion. But I think this human-friendly order provides more clarity in learning. Let's continue. We're ready to sort. We'll examine the individual items, compare their values, and merge them into temporary arrays. The temporary arrays are sorted, but there's work left to do. Let's jump up the recursion stack and continue. We merge our smaller arrays into a larger one, inserting items in the correct order. One more merge, and we'll have our sorted array.
Pretty easy.
And that's it. Our array is now sorted. Here's the pseudocode for merge sort. On the left, you have the recursive part, which halves the arrays. On the right is the merge function, which combines the arrays. Merge sort has a worst case time complexity of big O of n times log n. The easiest way to think about it is to start with the merge step. Looking at the while loop, we see we have to visit n items. The log n comes from the maximum height of a binary tree we create, which is on the order of log n. Thank you for watching.
So, all right, questions? Questions?
Are you making, are those while loops generated by how many things you have in the array?
Yeah, that's why we have n here.
Okay.
And log n is like 0.6. Is, for example, if n is equal to 1, then log n could be 0.6, right? About that. You can use a calculator. So I think it's the best sorting algorithm right now compared to the other three.
The best sorting algorithm depends on your data that you put in. If it's already kind of sorted, then bubble would be best.
Yeah,
depends.
It depends.
It depends
Randomly speaking, randomly. Yeah. So we have one big while, and then we have two elements here. We have two arrays, A and B. Okay, A and B. If one of them run out of the element, we call the other one. We call a smaller while loop here. It depends. Sometimes the array A run out of items, so we call this one. If the array B run out of items, we call this one, and then we return C. We see the result here. Okay, let's do it. We take in the array. We split it into two parts. first we have to guard against the case that it only have one element. So if r len r that's equal to 1, same thing, right? Return r, and then we split it in half. Let's call it left and right here. Okay, left is array, and then we start from 0 to what?
Halfway point.
Len r. We don't know if the length is odd or even, right? So we use this syntax. And then right side we have len r that's it.
Minus one, short at the end.
Nah,
All the way to the end right there, it says. I think.
it's by default is the end, and this is the start. Basically we are slicing the array. Okay, and then we gotta repeat this step again and again until we get only one item inside the array. So call it merge sort. Again left, okay, cool. Let's leave it there. Now here is the logic, the real logic. There, do something. How do we call it?
Merge.
Arranging, merge. Yeah, merge. Okay, it's a function. It takes arguments the left and the right. Okay, then we need to return something. We want to return a new array. Let's call it result. Okay, let's call it res in short. Return res. Okay, here, so here our function here need to return something. We return merge left, merge left and right. Cool. Now we don't need that. We replace it with this one. Keep it short. Okay. And here we have to do something. Remember the while loop, right? While something here and something there, left and right. Okay, left and right, len. Right. Same thing with len here. Correct? And then we do something. If something's wrong, I feel like something is wrong. Left. It's wrong. We using while, so we need to yield the index. We need the index. So index start from I and j equal to 0.
And J.
Oh my god. Nice. Remove the whole thing. While I less than len of left and j less than len of right. Okay.
Can you explain that part there?
Because right now we want to look through the left and right at the same time, parallelly. Yeah. So using
Saying
what?
empty array, and then you're saying I and J, the two things in the index, right?
Yeah, if there's something
So-
if there's something inside the array, we compare them. Okay, we looking
Is J
like
in this example your right index?
yep. J is the right index, and I is the left index. Okay, now we compare. Left I. If left I less than right J, then what are we gonna do?
You've got three square, and then you've got curly on the last line of array.
We append it to the array, the results. What were you talking?
The bracket on the right J, if
Right, it's the parentheses you
Oh
have.
shit!
Thank you, Hi.
Thank you. We append I. Okay. Why we need the equal there? Else we press append J. Ah shit. Append array I. Left. Right J. That's cool. Now we need to increment I after we append it, right? So could be I plus 1 J 1. Okay. What else? When one of the array here, when either left or right run out, right? Of item, we do another while here. While I still, for example, we take the left hand side first, okay? We do something, same thing, right? Press, append, left, I. Same thing, I. 1. While J less than len right. Press append J, and then J, then return rest.
Don't be like, you lost me there.
Where?
That whole section you did in the last minute.
The whole thing here, right?
Yeah, that whole bit.
So basically here we don't know how many items inside left and right. It depends on the input. We don't know. So sometimes the left hand side run out of item first, while the right hand side still have some item inside it, right? So this part will be trigger.
You cannot leave the first while. If either one of these still has items in it, you're still going to be in the this loop right here.
Yep.
Once these both have no items in it, then you move on to check either
No.
the left or
One
the right.
either of them have no item in it
Wow, either of them.
because we have and here. So it means both of them need to have some item inside, so we can trigger this logic.
But what? So what I'm trying to say is, so if one of them only has items in it, does this loop still continue?
No, it's not.
Yeah. Okay. So if once this exits right here, right? We're gonna this part right here is we're checking which one still has items in it, the left or the right, and then we continue doing the same magic with the right or the left one, whichever array still has some items in it.
Okay. Confusing.
Yeah, very confusing. Because I mean, I'm trying to think of it in terms of the visualization before, but you have breakdown into 8. It breaks down into individuals and then it merges them back.
Because
together.
what?
Whereas in this example, I don't feel like we're doing. Is that right?
No, we are combine them together. Like right now, the step that we put on the element inside the one big ass array is this one. The whole thing here. We take the first time when they merge it is the item left and right here only have one item in there. The second time it should be 2.
2.
The third one should be 4. It's like that. Right? Go back to the video here.
Can we look at each line where it checks each one again for me?
Okay. So the first time this function is called.
The first time we're passing in singles. Yeah,
Yeah, it's single.
Explain it as if it was singles.
The second time
No, the first time we're passing singles. Run it through.
Yeah. The first time is run one single in left and one single on right.
So
Okay.
the index is just 0 in both cases.
Yes. The second time, you have
Then
to
what?
how
I
do you-
get that each time it gets bigger, right? I understand that.
Because you know
Go
what?
through-
Because
you
it,
go through the function and explain.
it's like it's a recursive function, so it's very hard. Like you have a whole list like this, a print. When if you want to bring it, okay, let's do it. Let's bring it here.
No, I don't want to print it. I'm trying to explain. Like, put in 2 and 8, for example.
2 and 8.
Yeah, just put in 2 and 8, or 2, 8 and 4, and just imagine, like, explain that through in each step of where it goes in the functions.
2 and 8. For example, 2 and 8 here, right?
Yeah,
Take this example. Okay, take this one.
yeah, 2, 8, 3, and 5. Put them in and explain where
Okay.
they go each time and sort.
So the left hand side right now will be 2 and 8, and the right hand side will be 3 and 5.
Yeah.
Okay. The first step, we check, right? We compare 2 with 3. Okay, 2 is less than 3. We put 2 in rest. Okay. And we increase the increment I by 1.
To check 8.
Okay, now the left hand side array only have 8 left, right? Only 1 atom, and the right hand side we have 2. So that's why.
No. The array still has as many items in
Oh,
it,
yeah,
but we increase the I
We already
because
increased the I.
we've already grabbed out that 2. Where's it at? Where's the 2 at?
What 2?
Right here. That's what we're doing right here. So what you just said a second ago, check the 2, the 8, the 3, and the 5, right? So if 0 is less than whatever is inside of here, like, so let's just say we have 1 item in our left right here, guys, and then 1 item in our right. What's it gonna do next?
No, we still have 2 items in left and right. We still have 2 because I don't pop anything outside. I just increase the I. It's not the same with this one. They pop it, but I don't pop it. They remove it, I don't remove it. Okay, different ways. They remove it, I don't remove it.
Okay, so
I just increase the index
Iterator.
by 1. Yeah, iterator by 1. You don't have to follow exact.
no,
this.
it's not about following, it's about understanding.
Yeah.
Rather than, it doesn't, that's the thing, if we see their video where it breaks like that, I kind of don't feel like it's doing that in the code.
Yeah.
Which it isn't.
So
So sometimes illustrations for things don't actually exactly
you were
match.
saying it doesn't totally mirror the.
Yeah, it doesn't.
So I just want to keep the array intact. I don't want to mess up with the array. So I just increment the index. That's it. Right now is I here. I here will be 1. So it means 8. And on the right hand side you still have J is still 0. Okay, so that means they all still have 3 and 5. So the next loop, 3 will be compared with 8.
To the array.
3 will be compared with 8, and then you push 3 to there, and you have
that will increase J.
yeah, increase J, and then I is 1, and J is also 1, and you like do the whole thing again and again until you have like I is like I is equal right now this sample I J equal to the length of the array minus 1. You still have 8 left, so that means this condition is triggered. Okay,
So when the length of left.
so if you go with this one, let's see, same thing, the left is still there.
Are you sure it works? Can you show me that it works?
What are you talking about? You have to trust me.
I don't trust people. I don't even trust me. I could write it and I wouldn't trust me. Let's see it run first.
Let's see if there's no error. Cool. Wait. Oh, okay.
Amazing. Holy fuck. That's impressive, guys, man. If you guys can write this thing without looking at any notes, and that's off the top of your head, that's pretty fucking impressive.
See
Yeah.
how fast it is?
That's fucking incredible. I'm impressed, to be honest with you.
45 microseconds. It's much faster than the
random shuffle.
No,
The
no,
Bogo
the Bogo shot, right?
And it's definitely better than the Ed sword for sure.
Try this one. Okay. Wrong one. This one. Cool.
So you guys can see that Kwa has memorized these
Yeah,
algorithms.
I memorize everything. Don't worry. How about oh shit! Fuck! Oh Jesus! Who would do this? Man,
Okay, let's see if this works.
who?
No,
do that?
print it first. I want to print it first. Print it right here. Yeah. Print
No, it's 1,000.
it. No. But make
No,
this-
don't.
Let's make it 9. Yeah. And then now I want to look at it.
Why you? It works.
I want to see.
You can tell from here, right here.
No, because we.
It works. Right.
Incredible! It does work.
Just a matter of this one. 1,000.
Don't put 1,000. Oh no!
We are
Bogo
testing
sword.
the speed. We are testing the speed.
No, if it was Bogo sword, this would take forever. But
Yeah.
but this is the actual sword, so this could actually be done very quickly.
So we are confident that the function does correctly, right? Run correctly.
Does the sword work correctly? Look at the examples. It works.
Okay, now we are merge short, array, blah blah blah. Okay, let's test how long it takes. Wow.
1.4% of a second.
See this?
It's not even less than that.
See the difference? Much faster. And what if we percentage time short let's make a div copy first, okay? New array equal to copy dot copy deep copy for sure. My array. Okay, what the hell is that? And then we gotta do new array dot short. No, use the normal short, the built-in short for Python. What the fuck? You know why? Because the combination between merge short and insertion short should be faster than the normal one. Yay! What if I raise it to 1 million? So tell you wow. Bravo short. Dot short. Bravo dot short. How about new equal to let's try again. Sort it. New. Alright. Okay. Still pretty fast.
What are you trying to prove here?
I want to prove that the dot shot is faster. The built-in method is faster than this one because it uses the combination between the merge short and the insertion short. Insertion short.
That difference.
Another different algorithm. Okay. So there are two ways of doing it. You pop it after you append it, or you just increase the I.
Pop it, what do you mean?
Remove it from the array. Pop. Pop. Like this. Okay. Cool. Questions?
How many search algorithms are there?
Hmm?
How many search algorithms are there?
Insertion? How many?
How many search algorithms are there?
Oh,
Search or sort?
short. Are there? Yes. Someone already asked this.
Like 50?
2 times.
Okay, let's go.
It's 2 times. As it, like you can think of those two types, as ed sort and normal sort.
Extra another sort. The main drawback of motion is that you need to allocate more memory. Yes, because we are dividing it into different smaller arrays, right? So that's why it's consume a lot of memories. And the advantage is fast. Blah blah blah. I don't know. 20 about it. About 20.
I guess we're gonna do the primary ones.
Probably not Stephen.
Have the story out when you want it.
Any questions? Oh, sorry.
So when is merge short used in the real world?
Merge short, where is used? Right here, right now.
No, come on.
Okay.
I would let you off with that normally, but not now.
It depends on the if you have plenty of memories, you could use merge short because it's faster than the other ones, right? And it consumes more memories.
It's not only a wide number.
Yeah, you can use it in other case. Names okay? Yep.
So is it, for example, powering things like Google Sheets?
What Google Sheet?
Like, is Google Sheets using merge sort function?
Good question. Is Google Sheet using merge short? Oh, sorry.
It's going to be hard.
But you know, they are all the basic sorts. Okay, and many pros they invent the new sort. They like combine different one together, like team sort, for example. Team sort is the dot sort, the bean sort for Python. The reason why we learn this is just know the algorithm and how to use recursive function. Yeah.
I can see why. I was just wondering if it's used as well.
And maybe you go into an interview and then you have to like to say the pros and cons between merge short, quick short, bubble short, and something else, right? So you need to know the pros and cons of each one.
What's a real life example of merge short? Someone had 25 years of stock market tick data in 300 files. They wanted to combine the files and remove duplicate data. Some of them were not sourced by time. Each file was about 150 megabytes. They couldn't load all the data.